Alright, so let's take a look here at number 20, the last in this section. Again, performing the indicated operation and expressing in lowest terms. Since we're dealing with an expression, right, no equal sign, I like to stack my fractions, and that helps me to build a common denominator, stay organized. So we have m minus 2 over m squared plus 13m plus 40, and then we'll have 3m plus 1 over m squared plus 15m plus 56. Alright, so if you've watched any of the previous videos, you know that the first step we want to do is factor each of our denominators. And so here we have trinomial, no GCF, coefficient of our squared term is 1, so we're going to use the simplified version of either scissors or the AC method. And so we have m and m, looking for factors of 40 that add to positive 13, so I think plus 8 plus 5, right? 8 plus 5 is 13, 8 times 5 is 40, so that checks out. Same thing here, trinomial, no GCF, coefficient in front of our squared term is 1, so simplified version of scissors or AC tells us we're going to split the m. And then factors of 56 that add to positive 15, plus 8, plus 7. Alright, so let's see. And now let's actually start building that common denominator. Remember, the common denominator has to have one of each factor that's unique. Alright, so m plus 8, m plus 5. So m plus 8, m plus 5. And let's see, here's m plus 8 again, but we've already written it, right? We've already written it as part of our common denominator because it was in the first fraction. So we don't have to write it again. We only need to write it once, and by virtue of writing it once, it covers both occurrences in our original denominators. And so that's what we mean when we say we need to have one of each factor that's unique. And then we have m plus 7. Well, I didn't have an m plus 7 here in the first denominator, so we have to include m plus 7 as being part of the common denominator because m plus 7 is unique to this second denominator. And I don't see any other factors. We have m plus 8, m plus 5, m plus 7, m plus 8, m plus 5, m plus 7, so we are good to go. Now we have to decide what we're going to be multiplying by. And if we are trying to get to our common denominator of m plus 8, m plus 5, m plus 7, and we take a look here at what we originally had, which of the three are we missing? Well, m plus 8, m plus 8, m plus 5, m plus 5, so we are missing the m plus 7. So to get from here to here, we had to multiply by m plus 7. And we'll recall that whatever we do to the bottom, we have to do to the top. So we're going to multiply our numerator by m plus 7. Well, now we have to multiply m minus 2 times m plus 7. And that's just a FOIL, isn't it? M minus 2 times m plus 7. Well, we're going to have m times m. That gives us m squared. M times 7, that's plus 7m. Negative 2 times m, minus 2m. Negative 2 times positive 7, minus 14. Let's combine our like terms. So we have m squared plus 5m minus 14. So m squared plus 5m minus 14. And now let's do the same thing here with the second fraction. We originally had m plus 8, m plus 7. So which factor are we missing? Well, we're missing the m plus 5, so we had to multiply this original denominator by m plus 5 to get to the common denominator. And whatever we do to the bottom, we have to do to the top, so we're going to multiply by m plus 5. Well, here again, now we are foiling, right? Because we have to multiply the original numerator by what we multiplied the denominator by. So 3m plus 1 times m plus 5. 3m times m gives us 3m squared. 3m times 5 plus 15m. 1 times m plus m. 1 times 5 plus 5. And again, combining our like terms, we'll have 3m squared plus 16m plus 5. So 3m squared plus 16m plus 5. And I'm going to go ahead and I guess we'll get rid of that work there. All right, so now that we've built our common denominator, we've multiplied by everything we have to, let's go ahead and start getting to our expressing this in lowest term. So m plus 8, m plus 5, m plus 7. Our common denominator just moved over, and now we can go ahead and combine the numerators. So from here we have m squared plus 5m minus 14, and this is a positive 3m squared, so plus 3m squared plus 16m plus 5. Let's go ahead and combine like terms where we can. So we have an m squared and a 3m squared. That gives us 4m squared. All right, 5m and 16m is plus 21m. And negative 14 plus 5 is going to give us minus 9 over that common denominator, m plus 8, m plus 5, m plus 7. And now we're going to take a look at the numerator, see if we can factor the numerator in the chance that one of the factors from our numerator will end up canceling with something in the denominator. So let's go ahead and do that. We are dealing with a trinomial here that does not have a GCF. So we're going to either use the scissors or the AC method to try to find factors that will multiply together to give us this trinomial. But in the effort to save some time here, if you go ahead and try to factor this numerator, you're going to find that it's not going to factor, and so we're not going to be able to cancel anything with our denominator here. And so we're going to stop right here where we are, and this is actually our final answer. And so we have 4m squared plus 21m minus 9 over that common denominator we built of the factors m plus 8, m plus 5, m plus 7. All right, well that was number 20, the last in this section. We're going to take a look at 21 in the next section, where instead of dealing with rational expressions, now we're going to be dealing with rational equations. All right, so I will see you there.